Welcome back. Okay, so in this video we're going to look at how to implement the get method of our linked list. So let's take a look at the documentation for get, and it looks like it's right here. It returns something of type E. Remember, E is the type of data that's stored in our linked list, so that makes sense because we're returning the element at the specified position in the list, and this position is specified by this parameter called index, and then it just returns that element. And then we have this special exception here, index out of bounds exception, if the index is out of range. So if you used an index that doesn't actually exist in the list, then we would just throw that index out of bounds exception. So let's go right into implementing this. To find our get right here, we're going to say, first let's deal with if the index is out of range. So if I is less than 0 or I is greater than or equal to size, that means that it's out of bounds. It's greater than or equal to size now because if I is equal to size, that means it's one after the end, one index greater than where the end of the list is, since the end of the list is at size -1. So in that case, we're going to want to throw new index out of bounds exception, just like that. Okay, so now that we've got that exception out of the way, let's just worry about actually implementing our get method. So now there's two cases here basically. If the I is less than size -1, that means that it's before the last node in the list. Size -1 is where the actual last node is. So in this case, we're going to have to, in all these cases, we're going to have to loop through to find the node in the list. So that'll be node E current equals head. We're going to do a similar thing like we did with our add method down here, where we looped through the list up to a certain index. So we're going to say int j equals 0, j is less than I, so that'll get us right up to I. And then for each of these, we're going to do current equals current dot get next. That way we're advancing the node that we're at each time. And so by the time this loop is over, we'll have advanced current ahead I times. And that will leave us at the correct index that we want. So what we'll do here is we'll just return current dot get data, because that will get us the element at that index of type E. So now the other case here is if the node is actually at the very end of the list. And what we're going to want to do in that case is actually, we don't even need to put an else here since we're already returning the data up here. There's no reason for an else. So if the what's left is the case where I equals size -1, which means that the data that we want is just right at the tail. So return tail dot get data. Now we could have not used this case right here and just gotten rid of this if statement and looped through all the way to the tail, but that would be less time efficient than doing it this way. So that's why we've done it like that. And now that we have a get method, it's probably a good time to test that both our adding and our getting are working correctly. So I'm going to move back over to main.java and start adding some stuff to our list. We have this as a linked list of strings, so I'm going to start adding some strings into the list, just like this. This will test our, this is testing our add to the end method, so this should add 1 and then 2 into our list. Now let's add some testing for our other add method. So let's say we'll add it right at the beginning of the list. We'll add a 3, and then maybe at index, let's say 2, we'll add a 4. So what do we expect this is going to leave our list looking like? We should have a, let's see, we should have a 1 pointing to a 2, and then after this line right here, then we should get a 3 right at the beginning there, pointing to that 1. And then after we add at 2, that should be, this is index 0, 1, 2. So right at this point, we're going to add in that 4. So that's what our list should look like now. And the way that we'll test that it does that correctly is we can just print out list.get at 0 and list.get at 1 and list.get at 2 and list.get at 3. And maybe just to test some other functionality here, we can try list.get at 4, which should throw our index out of bounds exception. So if we run this, what we should expect is we should print out a 3, a 1, a 4, and then a 2, and then an index out of bounds exception. So let's run this, see if that's what we get. Let's see, we got a 3, a 1, a 4, and then a 2, and then we have this exception, index out of bounds exception. So that looks like what we were expecting to get here.